So this is a webinar on uncertainty quantification. I've got this agenda built for today, a bit of a problem statement of why this is important, and then some words on different uncertainty types you have to be aware of, an introduction to elicitation process to clarify uncertain values and to try to get your arms around that to come with a good estimate. And when you're estimating, it's important to understand biases. We all have biases, so I've got some words on that. Then I'll go to the little freeware I built, the uncertainty range quantification. I'll show you the tool and I show you how to use it in that exercise. And then I want to wrap up. And the tool you can download at my website, and that's shown here at the bottom. So the problem statement. Hindsight analysis shows that we are not very good at estimating uncertain values and also estimating the uncertainty of those values. I think we have all experienced that in hindsight our estimates were off and quite often way off, and also that the range of our uncertainties were not capturing the answer. And so common practice is, this is Dilbert's practice, and I think that is a bit of a common practice in our industry, that we just make up numbers and we don't think further about it, and that's it. I built this tool to try to do something about it, and it's not that difficult to do something about it. Just some simple techniques. You can become a better estimator and get better estimates for example, for your volume calculations, for your input parameters. A bit on uncertainty types and uncertainty distributions. There are statistical uncertainties, that are uncertainties related to variability in data and measurements. And there are epistemic uncertainties that is related to ignorance, and that's caused by incomplete knowledge or information. So these are different type of uncertainties, and they relate to different type of data. So you've got data distribution, and that is a description of the data variability, and there are statistical methods to describe your data and to come to an uncertainty distribution. Epistemic uncertainties, they give uncertainty distributions. So these are data distributions, these are uncertainty distributions. And the uncertainty distribution is a description of the uncertainty. And there are many different uncertainty distributions. You've got single values that cluster around the best estimate or a best case, and you can have also multi either or values. You can deal with alternative scenarios to try to deal with that. And what I'm going to talk about here are epistemic uncertainties. So statistical uncertainties, they are just statistical methods to get your distributions and your standard deviation, etc. I'm going to talk about epistemic uncertainties. So it's related to ignorance or incomplete knowledge. And that gives uncertainty distribution, and I'm going to talk only about the single value uncertainty distributions that cluster around the best estimator or base case. If you are in the case of a multi either or value, you will have to deal with alternative scenarios, and I will have a webinar next Friday, analysis of competing hypotheses, to try to deal with uncertainties related to multiple hypotheses. There is an elicitation process to get your arms around the uncertainties, to try to estimate those uncertainties. And the objective of the elicitation process is to obtain a probability distribution. And the probability distribution should describe the underlying knowledge of the knowledge holder. The problem is that conscious and subconscious discrepancy between the responses you get from the knowledge holder and an accurate description of the underlying knowledge, and that's called the biases. So the problem are biases, that we do not get the right answers to make this description of the uncertainty distribution. And the sources of biases can be classified as motivational biases and cognitive biases. I have a few words on those biases. And motivational biases are people may have incentives to reach certain conclusions or see things in certain ways. That is very common in our industry, that there is a motivational issue related with that. So net pay estimates tend to be bigger than what they in reality are, or predicted oil volumes in general are larger than the actuals, etc. So there's a general bias in our industry to come up with bigger numbers for certain parameters. So that's a motivational bias. The other biases mentioned here: availability, representative, adjustment, anchoring, assumptions, coherence, etc. All those biases are cognitive biases, and that is related to our thinking process. Availability bias is a tendency to give too much weight to readily available data or recent experience. The first thing that comes into mind that we think that is the right answer. Adjustment and anchoring, we might give unduly weight towards a conventional value. We might anchor it in a certain value. And representative and state, there are a whole list of biases, and there's a lot of literature on that. And if you're interested, I really recommend you to read on that, because it helps you to make a better estimator. And the elicitation process goes as follows. It's a structured interview of a knowledge holder. In general, it takes between 10 and 90 minutes to come to an estimate. So you will have to invest some time to come to an estimate. And the interview helps to translate the knowledge of the knowledge holder into a probability distribution. So in general, you have at least two persons, an interviewer and a knowledge holder, or it could also be a group of knowledge holders. And the interviewer can help to detect and correct for biases during that process. So that's how that process goes, and the interviewing can challenge the knowledge holder during that process. So how does this interview process go? It's a simple 4-step process. You start with structuring the discussion. So you have to clarify the variable you talk about. You have to get agreement on the scale. You have to look for implicit or explicit assumptions that could impact the estimate. So basically, it's a clarification before you start on the road of estimating it. The next step is you start with the extremes. You start with how large could it be or how small could it be. And once you're at the extremes, once you have defined those extremes, you work yourself towards the middle. And that's in the encoding process when you work yourself to the middle. And you work from the extremes towards the middle, and you have probability questions and value questions. A probability question is that if the interviewer gives a probability, say a P50, a 50% chance that's larger or smaller than that number, and then the knowledge holder will come with a value for that probability. And a value question is the opposite. When the interviewer gives a value, it says, well, let's say that you're trying to estimate the oil price, and the interview says, well, what do you think 50 if the oil price is $50 at the end of the year? What probability do you give that? So he gives a value, and the knowledge holder will give a probability back. When you go through that process, then you get the distribution out of that. There are 5 methods built into the tool: a min-max method, a 3-point method, a larger, smaller method, a closer method, and a bin method. And so you can choose any method you want. So some people prefer one method over the other, and I want to go through those methods with you. And then after you encode it, you verify it, you check what distribution you get out of it, you do a reality check on it, and maybe you will have to recycle. Maybe you think it doesn't represent really your knowledge, that distribution, so you might have to recycle through the process again. It's a very simple 4 steps, and that's why the interview takes between 10 and say 90 minutes to get done. There's a betting analogy for uncertainty estimate that is being used, and the analogy is that you compare your probability with known probabilities. And if there's a balance between this comparison, then the probability you try to estimate is equal to the known probability. In the tool, we use a probability wheel. So in the probability wheel, you try to estimate what is the chance that you get into the green slice of the pizza. Uncertainty range quantification, there are 5 methods, and there's a combined method, so in total 6. a min-max method, a 3-point method, a larger, smaller method, a closer method, a bin method, and a combined method. So these are the methods in the tool, and I want to demo it quickly with you guys, and I hope you will volunteer so we can go through the process of getting a distribution. I gave this webinar before in April 2nd, and what we did there, we estimated the following uncertain parameter, that's how many worldwide COVID cases will be there at May 1st. And so now, of course, we know the outcome of that. So at the time, this was the situation in the world with COVID. This is from the Johns Hopkins website. So there were 1 million confirmed cases. And here you see the graphs of this is the cumulative graph on a logarithmic scale. This is the cumulative graph on a linear scale. And these are the number of cases which were really ramping up at that time. So there was at that time there was an exponential growth of cases, and this was the time when the lockdown started and when I started with those webinars. So the question is, where will this curve go and where will this curve go? That was the question. This is where we were at that time, and we went quickly through the process, and as a group we came with a P90 prediction here, a P50 prediction here, P10 prediction there. So the P10 prediction really is that this exponential growth continues, so that it would go up there. This flattening curve really is this would flatten out, and this would be something intermediate. This is the estimate we made at that time. Now we know, of course, the actual. This is the actual. So actually the actual was slightly above the P90. So these were way too pessimistic in hindsight. And so actually the curve you see here, it actually went down instead of the exponential curve growing up. And so these are the daily cases, and here the world went into lockdown, and here things were being relaxed and it's ramping up again, those cases. And so for me now the question is, where will this go? And so if you highlight again, so will this go there, or will this go there, or will this go there, or in the cumulative, that would be in the cumulative curve, will it go there, or where will this cumulative curve end up at the end of July? So I want to go through an exercise with you guys to make an estimate of that. And so, of course, I mean, this COVID is interesting where this is going, but basically I would like to show the tool how to go about making an estimate. And so the next question is, how many cases are there on August 1st? This is the tool. And so here there's the min-max method, the 3-point method, the larger, smaller method, the closer, bin, etc. Who wants to volunteer to go through this?
I can do it, but
okay.
I sort of have an issue that I don't believe the measured world cases are anywhere close to reality.
I agree with that, but I just want us to estimate what are the cases as reported by the Johns Hopkins website of what the cases are.
Okay.
Yeah, let's estimate just where does this curve go. Here you see there was an exponential growth. It was flattening after China. It was flattening out. It became linear. There was again an exponential growth here, and that's here. It's flattening again, but it seems that we are entering again in an exponential growth. So the question is, what will happen with this cumulative curve? Where will we end up? Will we end up at here? This is 10 million. This is 100 million. This is a logarithmic scale. This is 10 million. This is 100 million. At the moment, we are around 7 million. So it will be more than 7 million. So the question is, where do you think we will end up? Yeah, okay. Let's go through the tool. I'll try to capture your ideas in this tool. The easiest method is the min-max method. That's the easiest to handle. You you just need two numbers, the minimum and the maximum, and it estimates of that. Let's start with there. What is your professional best estimate? Where do you think, if you just think now, where will it end up? Where will it end up here? What do you think?
Probably, best guess, around 500 million.
500 million. Wow. 500 million. So it really will go all the way here. Huh?
Yeah.
That's where you think it will going. Okay. So if I will draw that, so then you think this will go there?
Oh, I thought you were going for the P90, P50, P90. I would draw the P90, the slope a little bit lower than that, so maybe 250.
Yeah, okay, no, but but your best estimate where it will end up is at 500.
Best guess, yeah.
That's used as 500. So what is the minimum? How small could it be, and how large could it be?
It can't be. It's not going to be any less than 200.
Not less than 200. Huh? Wow, you're very pessimistic today. And the maximum?
The maximum? It could be 1 billion.
1 billion. So 1,000. Huh?
Yeah.
So with this, if this is so, this is then the uncertainty distribution you get out of it. So this is the minimum. This is the maximum. It's an exponential distribution, and here you see the mean is 475. So this mean is just based on this minimum and this maximum. So here you can still say, well, what is the odd that it's larger than the minimum, or smaller than the minimum, or larger than the maximum? You can change those distributions by defining what is the odd of being larger or smaller than that number. If you look at this distribution, this kind of represents your thinking on this?
Yeah.
Yeah? Okay.
Yeah.
So that is John's estimate.
Yeah, it's ramping up and they change. So
okay. So now basically I try to capture your belief system. I mean, it is an epistemic uncertainty. We don't know. But everybody has got different thought processes. So I'm trying to capture here your belief system on what is going on there. Yeah. Somebody else wants to try. I want to try this 3-point method. Somebody else wants to step in for that. Ash or Ben or Patricio.
I'll give it a go.
What do you think is your provisional best estimate where this will go?
So best estimate, I think, from where we are now. Cumulative cases, so 100 million.
So you think it will go to 100? Yeah.
Yeah.
So if I draw it, it will ramp up here and go there.
Yeah, and then flatten. Yeah.
That is where you are. Huh? Okay.
That's why I think it's similar to before, but on a bigger scale. But I don't think we'll see a sustained period of sort of.
Okay.
Yeah, exponential growth.
So best estimate. What's the absolute minimum?
70 million.
It can't be lower than 70?
I don't think so, no. I think just big countries like Indonesia and India and China are gonna have second waves or first waves that are substantial. Yeah. So I think even with best efforts, I don't think they'll keep it globally below that.
And absolute maximum?
600.
600.
Yeah, I think depending on how much control on lockdown type policies that various governments can put in place.
Yeah.
Clearly they do work, but it's whether or not they're enforceable in different parts of the world.
Yeah.
Brazil, for example.
And like here in the US, people are just fed up with it. I mean, and so now what I'm going to ask you now, so now I've got, this is a 3-point method. So I've got your provisional best estimate, which is basically I ask you that just to get it out of your system. But the method is really about the absolute minimum, absolute maximum, and the P90, P50, and P10.
Okay.
So now the question is, the P90, the 90% chance that the value is larger than what number?
90% chance is going to be larger than 80.
80. And the 50% that's larger than what number?
50-50. That's tough, actually. But I kind of have, 200.
200.
50-50. Yeah, no, because then I'm kind of moving away from my best estimate or showing
okay. No, but that's you don't have to be internal consistent in the sense.
Okay.
I'm trying to understand your thought processes here.
Yeah.
You might change your mind during this process.
Yeah, very good. Yeah.
Yeah.
Because
200. You think more about it while you're doing this, so you might shift your position. Don't worry about it. Don't worry about being internal consistent. I just try to understand what you think. And so a 10% chance that it's larger than what?
500.
500.
I think. A lot of systems will be put in place to stop that.
So now we've got 3 numbers. We've got a minimum, a maximum, and those P90, P50, P10. And it tries to fit the distribution to that. Yeah.
Okay.
And so that distribution looks like that, and that would mean actually the mean is actually 245. Your best estimate was 100, but actually the mean of this distribution is 245. Actually, your best estimate is very close to your P90. Yeah, you see that?
Yeah, very interesting.
So you think this represents kind of your thought process, or do you want to change it? So now I'm in the phase that we went through the process and we might want to recycle.
Yeah. I think I'm probably happier with my step 3 answers now I've gone through the process.
Okay. So that means that your best estimate really is 245.
Yeah.
You're happy with that?
Well, it depends how much money we're putting on it, but yeah, largely.
Okay, I'll save this. Now I want to get to a slightly more complicated method, the larger, smaller method, and I need another volunteer for that.
I can come up.
Okay. Okay, perfect. So that's Ash.
Yes.
Okay, so what's your provisional best estimate then?
150 million.
150. And so the absolute minimum?
120.
120, and the absolute maximum?
200.
200. Okay. Yeah. So now we've got an absolute minimum, maximum. This is just to get that out of your system, and I'm going to work now with those numbers. With the absolute minimum, maximum. That's where you are, and I'm going to ask you several questions. And so this is a larger, smaller method. It asks you if the actual is larger or smaller than this number. So now I give you a number, I give you a value question, 139. Is it? You think the actual will be larger or smaller than that?
Larger.
And here we try to assign the probability with this probability wheel. And so here, what is the probability? When do you think there's an equal probability? If you throw a dart, on this thing, there's an equal probability that as this bet, you're betting it's larger, but there's uncertainty around it. So what kind of bet do you place on it? Do I make myself clear?
Yes, I think so.
Yeah. So where are you? Where are you?
I'm at about 70%.
Okay. Now I go to the next sample. Is it smaller or larger?
Larger.
162. It's larger?
Yeah.
Okay. And where are you? What's the probability there? That is larger?
About 60%.
Okay. Smaller or larger? 181.
Smaller.
Yeah. And where are you? What's the likelihood that it's smaller?
About 50%.
About 50. So it's a kind of 50-50. Yep.
Yeah.
Smaller or larger? 190.
Smaller.
Yeah. And where are you?
At about 45%.
Yeah, but so 45, so there will be 55.
Yeah.
50. So there's a 55% chance that it's smaller than that. And that's 45% chance it's larger than that.
Yes.
Okay, 195.
Smaller.
Yeah. What's the chance that it's smaller?
About 60.
60. Smaller or larger? 197.
Smaller.
What's the chance that it's smaller?
About 70%.
70. Smaller or larger? 198.
Smaller.
Yeah.
About 65%.
65. Smaller or larger? 199.
Smaller again.
Yeah.
About 70%.
Okay. And this is the last. So now we have got 9 out of 9. I asked for 9 bets. So this is the last bet. 196.
Smaller again.
Yeah. And
about
is
75%.
Okay. So these are your bets. So you see that during you start with your provisional best estimate 170, but your bets really shows that you're get very close to your maximum 200. Probably this maximum doesn't reflect really the maximum you believe, because a lot of those bets which are very close, they've got still a 30-40% chance that it's larger than those. You see that?
Yes.
So that's why now this distribution is kind of being truncated here at 200. It seems that your belief system is like smaller than 150 than those numbers. It gets very unlikely. Yeah, but I think looking at this, I think there is in your belief system there's a probability that it is larger actually than your absolute maximum.
Yeah.
But so that means that we'll have to recycle, but I'm not going to recycle because I want to go through the next method. I just keep it like this. Yeah?
Okay.
Okay. So I save that for Ash. And the closer method is very similar as the larger or smaller method. So if I would use your numbers for the closer method, but now I use this, I put a higher number here because that seems that was happening with you. And Ash, maybe we could also go through then, we recycle it, but we recycle it through a different method. And I just put in a larger maximum and see where we end up now. Is that okay?
That's fine.
So it's okay if I make the absolute maximum at 500?
Yes.
Something like that? Okay. So now there are 2 estimates, estimate A and estimate B. And now you have to think of the actual. The actual, will that be closer to A or closer to B? So the actual, this is 405, 485. The actual might be here it might be 500, it might be in between, it might also be 100. So 100 is closer to A. So where do you think the actual will be if you compare those two numbers?
B.
It will be closer to B?
Yeah.
Wow, but that is very high number. You see, I mean, your best estimate 150. 150 is closer to A. And
That
so
was better, but I believe higher.
you think that B is closer to the actual than this one, than A?
Yes.
Okay. So what kind of bet do you put on that? If I give you a bet for this, what kind of probability do you give on that bet?
50-50.
50-50. Okay. 351 and 422. Which is closer? The actual. Would it be closer to B or closer to A?
I'd say A.
Yeah. And what kind of probability do you give it?
Again, I think 50-50.
Okay. 189 and 283.
B.
B. What kind of probability?
65.
284 or 263. Which is closer to the actual?
A.
Yeah. And where do you think you are?
60%.
60%. 279 and 378. So you see, I'm asking for 10 bets, and we are now at bet number 5. 279 and 378.
B.
B. Yeah.
55.
55. 345 and 466.
A.
Yeah.
70%.
168 and 302.
B.
B.
70.
305 and 435.
A. 70.
201 and 330.
B.
Yeah.
65.
And 309, this is the last bet, 309 and 329.
A. 70.
Okay. So these are your bets. Yeah. And you see there are kind of some inconsistency in the bets. Yeah. So at certain bets you bet against yourself. So there's some inconsistency here. So that also I also suggest that we should recycle. And it kind of gives a uniform distribution between the minimum and the maximum, kind of flat, kind of straight line. So your mean. So this is hash number 2. The mean would be 323. So now we've gone, thanks Ash. So we went through those 4 methods. There's a last method which I will quickly show you how that goes. So here I just, again, a best estimate, a minimum, maximum, and here it defines different bins between those. And here you just have to say, how likely is it that it will fall in that bin? So let's make this extremely unlikely, maybe neutral, maybe likely, or very likely. Likely. So I just try to kind of build, say that I just give likelihoods that it's in certain bin. that is kind of my view then, and it builds a distribution to those, and that would be the distribution. Let's call this my distribution. Steve. So now, what we've done now, so we did estimates on the same uncertain variable, an epistemic uncertainty. We really don't know, and we just try to get our arms around. And now there's here a last method I want to show you. That is the combined method. And here I can combine all those different estimates. So this was Ash, this was Ash2, this was Ben, this was John, and this is Steve. So now we've got all these sin lines are estimates from individuals, and this is then the combined estimate of the group, or if you do it at the chart. So these were the different estimates from the different people, and this is the combined estimate from all of us. And in general, when you combine estimates from different people, you will get a better estimate. And so you can weight those different estimates if you think, well, I trust one estimate more than that. So you can kind of add some sophistications if you want, but this is now our combined view, and so make that combined. So create new. So our combined view would be that the P90 is 150, the P50 is 269, and the P10 is 440. Yeah. So the P90 actually is ramping up. If you would draw it in this graph, highlighted. So the P90 was 100 and what was the P9? 150. Yeah. So P90 would go there. Let's see again. P90 150, P50 260. So it all would end up there. There's this worry that this exponential growth will continue. And so it's not. We don't think it's flattening out here. No, it will grow. Is that correct? Is that where the belief system is? I think that comes out of those numbers.
Yeah, I think so.
Okay.
Yeah, I agree.
Okay. Well, that's very sad, and for all of us.
It's unfortunately it's reality.
Yeah.
or not. I don't think there's any reality in the numbers, unfortunately.
Yeah. Okay, so let's continue. So we went through that. So you see, I mean, you structure it, you conditioned extremes, you encode it, and you verify, and you might have to recycle. And so maybe we have to recycle a bit. But I said it takes between 10 and 90 minutes an interview. And I mean, I just want to continue here. And so if you aggregate independent estimates, when you have got a set of independent estimates, and it's important that they're independent. In this case, those estimates were not fully independent because people saw the estimate of the other one. So you might get anchors there. I'm the first one who estimated. John was the first one who came up and estimated. Other people might anchor their estimate on what John did. That's this groupthink where we tend to go with the crowd. But you need independent estimates, and if you combine them in general, you get a better estimate. And in combining expert opinions, one runs the risk of masking expert disagreements. That is one thing. Here also a bit overconfidence. People make in general their ranges too narrow. Common biases. Groupthink, I mentioned that. Basically, here are some wrap-up thoughts of mine. Also, you can train yourself becoming a better estimator with regular feedback. Now we made this estimate. So if you go and look back in 1.5 months when the actuals come in, you can see, well, okay, how did we do? Were we optimistic or pessimistic? Did we capture the answer at least? Let's see what happens. And independent estimates will improve the predictive capability. So final slide. I run workshops on critical thinking and prospect evaluation. And in those workshops, I go through prospects from my clients, and I use kind of this little diagram, it's got here challenge and here empathy. And we try to be here in the what they call radical candor. That's after Kim Scott. And that you need to challenge. It is important to challenge opinions and to challenge each other, but you need to do it with some empathy, and not otherwise it's just aggression and people close up and don't like it anymore. But if you don't challenge, then and you only have empathy, then basically you're in a ruinous empathy. Basically, you don't learn anything. So in those workshops, I definitely will challenge the participants on their prospect evaluations, but I try to do that in a nice way that we get through it. You can download the application, as I said, there, and you can contact me here. And so that was really it. Are there any questions? I think we're kind of, I think it's clear, isn't it? So I hope you use the tool, and it has served me very well in the past, and I still use it a lot to try to clarify variables and to try to have a discussion around it. The nice thing is, with this type of interview style, you can have a discussion around your variables instead of a discussion about numbers. You try to understand the belief system of something and try to translate it in a probability distribution. So I use it for estimating porosities or net base thickness, etc., for all kind of geological parameters, and try to have a discussion with the people around that, and it can bring clarity to their thought processes of what they believe. And also, if you do it with different persons and you combine it, you see, well, different people will believe different things, and it's a big learning exercise. I think it's very helpful to you. So I hope you will put that in practice.